Amgician channel. In this video, we are going to teach what is matrix. Matrix is the singular word while matrices is the plural form. And what are its types we are going to learn today. Yes. So when I can make the matrix, formation of a matrix, so we can collect some real numbers, arrange in a specified manner, after that enclosed in a bracket. It should be your square bracket. So it will forms the matrix. Yes, what I am doing, how I can make the matrix. I'm taking some numbers. I am enclosing in a bracket. So this will give me a matrix. How I can arrange the numbers in a specified manner. So for this we have to learn the rows and the columns. So first we have to know about it. Those numbers I am using here, I can use any number, collection of real numbers, and real number should be any number. So, if those numbers I am taking for the formation of a matrix, they are known as the entries or the elements of a matrix. And once I am taking these elements and I am making the matrix, so how I can denote it these kind of matrices? I can take any capital letter and I can show the matrix by using them. Just like this is my matrix and I can show it by any alphabet letter. Just this is A matrix and A matrix is equals to this. Just like this is B matrix and the B whole matrix is equals to this. So I can use any capital alphabet for showing the matrix. Yes. So move on the next. A very important topic. What are the rows and the columns? Remember they are showing these horizontal lines while in the next they are showing some vertical lines. It means the horizontal lines, those entries presented in horizontal way, they are rows, while those entries, those numbers you are presenting in vertical way are known as columns of matrix. If I have matrix A, yes, and I am collecting all these numbers and I am arranged in a specified manner, just like in matrix, in and rows and the columns, and I have to give some space between the numbers. So I remember it. Rows, the horizontal lines will give you the number of rows. Just like this one is R1, this one will be R2, rows number 2, rows number 3. How many rows I have? It means how many horizontal lines I have. In enclosed of that bracket, that is the matrix. How many rows? I have 3 rows. Okay, how many columns I have? I have 3 columns. So can I name as column number 1 C1, column number 2 C2, column number 3 C3. So remember one thing, rows and the columns. These are very important in your matrices. Okay, one more term that is order of a matrix. What is it? It's according to rows and the columns. How many rows? How many columns? This will give you the order of a matrix. Let's suppose I have a matrix M. How many rows I have? 2 rows. I can write it to how many columns I have? I have 3 columns. We know the vertical line should be your columns. I have three columns. So how I can write the order 2 by 3? First, you have to note down the number of rows, then multiply, put the multiplied sign in it, and show the columns, number of the columns there. There is no need to multiply, just these numbers will indicate how many rows here. This number will indicate how many columns there. So how we can write the order of a matrix? We have to multiply, we have to take the number of rows, just like I have how many rows? I have 3 rows. How many columns? I have 3 columns. So my order will be 3 by 3 matrix, because how many rows? 3. How many columns? 3. So how I can say it? It's a 3 by 3 matrix. It's a 3 by 3 matrix. And what about this matrix? A very interesting type. One row, while 3 columns. So what is it? It's a 1 by 3. How you can write the order for this? 1 by 3. We are not getting or multiplying, just it indicates you. The 1 is for number of rows and 3 will indicate number of columns there. This should be your order of a matrix. Now, move on how two matrices will be equal. So before going to take a start of these types, first we have to understand the criteria of the matrix, how it should be equal. So let's suppose I'm considering two matrices. A and B are two matrices. Plural form is matrices. And I can say A is said to be equal to B. I can denote it by using the equal sign. How is it possible? Yes, their order should be equal. If it is 2 by 2, it also be 2 by 2 matrices. The rows and the number of the columns both will be same. If 3 rows, so it should be the next should be 3 columns. So both will be same. If I this matrix, if this matrix having 2 rows, 2 columns. So this should be having 2 rows, 2 columns. And what about the next? How it should be equal? Their corresponding entries should be equal. Those entries are coming there just like it's 1. Okay, it's having 1. It's having -4. Okay, it's having -4. There's corresponding entries. If 3 is here, it should be 3. Look at, let's just expand this, but it's 3. It's 2. Look at, it's again 2. So can I say it's A and B are equal? Yes, these are the equal matrices. While if I'm taking this example, I have this L matrix, I have this M matrix. Check it out, it's same or not? 2. Okay, this is 2. This is -1. This is -1. This is 3. This is 3. This is 2. Oh, this is -2. So they are not the equal matrices. Order is same. 2 by 2 matrix, 2 by 2 matrix. Because 2 rows, 2 column, 2 rows, 2 column. But the next rule is about to the elements. If the elements are different, it should not equal. If the rows and columns are not equal, it should not equal. But there is the problem here. Why it's not same? Because entries in the second row, look at here, it's second row and the second column. What about it? It's a second column. It's not same. So we can say L is not equal to M. Okay, now what about the P situation? see P matrix, the order of this matrix, two rows and two columns, 2 by 2. Look at here the Q matrix having two rows while three columns. Their order is not same. It means they are not equal. Why we are looking the elements? If the order is same, then we look the elements. Look at both having the same situation. That's why we comparing these elements. But they are not the same. They having 2 by 2, two rows, two columns. While in this, two rows, three columns. So we can't compare these. They are not the equal. They're for equal. Remember two things in your mind. Their order should be same, their entries should be same, so we can say both matrices are equal matrices. Okay, so I hope you have understood all the criteria for the matrices. What are rows, what are columns, what is order, what are equal. Okay, so move on towards the types of the matrices. So take a start from the first type, that is raw matrix. As the name suggests, a number of rows? No, no. A matrix is called a raw matrix. You know what is the unique thing here? If it has only one row, so it should be your raw matrix. How is it? Let's suppose I have a matrix M and this having only one row. That's why it's called your raw matrix. Look at here. How many rows? One row. Because the horizontal line always gives you the number of rows, but I have only one lane here. That's why it's your raw matrix. While in the next type, that is reverse of it, that is column matrix. Definitely, what will be the unique? Yes, uniqueness here. If it is has only one column, that's great. It's the unique property of it. In column, as the name suggests, if it is has only one column. Let's suppose I have a matrix M. I am observing here I have only one column. What I am observing here, I have only one column. It means I have only one vertical line. That's why it's called column matrix. While a number of rows are here. Look, look, look. How many number of rows? But we are not considering rows. The uniqueness here, that is only one column. While in the raw matrix, only one row. So now we have learned two raw matrix and the column matrix type. Now we are moving towards the third type, that is your rectangular matrix. You know what you are doing here? As the name suggests, rectangular matrix. How is it possible? You know, when the number of the rows is not equal to the number of columns, then you can make the rectangular matrix. How? If both are same, it makes a square. But it both are not same. Just like look, how many rows? Three rows. How many columns? Two columns. And look, it's proper rectangular form. That's why it's called rectangular matrix. So we can say A matrix is your rectangular matrix type. What about this for B? Look at how many rows? Two rows. How many columns? Three columns. They are not the same. What they are making? Rectangle. What kind of shape they are making? A rectangular type. That's why it's called the rectangular matrix. What about it? Again, the number of rows and columns are different and it's give you the rectangle. Again, it gives you the rectangular shape. So that's why it's called rectangular matrix. Very interesting. Yes, move on the fourth type. What is it? Hmm. Square. If you're making the rectangular, so why not you are making the square? Reverse of it, number of rows should be equal to the number of columns. So you can make or design your square matrix. Is it possible easily? If I have two rows, I have two columns, a proper square is formed. That's why it's called the square matrix. What about this kind? I have three rows, I have three columns. The proper square is formed. That's why it's because every side is same. It's in square matrix. And look at how it's interesting. One row, one column. It's square. Both are the same. So everywhere you are looking the rows and the columns and then you are deciding which kind of matrix is given to you. Okay, move on the next time. That is your null or zero matrix. A matrix is called a null. What is null? Null means N-U-L-L, that is empty. Nothing you have, no anything. Or if you have no number, it means you have a zero number. So can I call null matrix it's a zero matrix? A null matrix is also known as a zero matrix. So what type of these? Look at if I am considering any kind of matrix here, but all the numbers, all the elements, all the entries are zero. So this kind of matrix is your null or zero type. Zero matrix. Look at here. Look at every element, every entries, how I am arranging these, but having the zero, I'm making different orders, but all are belonging to the zero matrix, or we can say it's a null matrix. And how we are representing by? Note that null matrix is represented by look at. So interesting. Move on the next time. A very interesting part. You know what you are doing in the next type? Transpose. Transpose. I have this A. I am changing into the transpose. I am making from it. And how I'm showing it? Denoted by what I'm doing? T at the top. Just like B. What about B transposed? B T at the top. C is equals to this, but if I am making C transpose, so I am showing this small t on the top, just like the power. How we can make it or convert it in? A very interesting part. What you are doing, how you are obtain this? By interchanging the rows into columns. Rows into columns, or you can say columns into rows. You know, I'm writing 1 2 3, those numbers are given me in the rows, I'm showing here in the column. Those numbers they are showing to you here in the row 2, I am writing in the column 2. Those numbers they are giving in the R3, I am showing in the C3. So that's why it's known as transpose of a matrix. Why? How we are obtain this? By interchanging the rows into columns or the columns into rows. It's called transpose of that matrix. So it's interesting. You can take any matrix and make the transpose converted into rows will be columns, columns will be rows, and get the transpose. Okay. So the next type is negative of a matrix. If any matrix is given to you, It means a plus matrix A. Plus matrix is given to you, but you are taking its negative. You are doing it by multiplying the negative sign. That's why it's known as a negative of a matrix. You are changing of any matrix into negative of a matrix by multiplication of the negative sign. Okay, if I'm multiplying minus, it's 1 becomes minus 1. What about this minus 2? Minus is already here. Multiply with the minus. Minus minus fight together. It should be plus 2. What about this 3? Minus 3. What about this 4? Minus 4. Actually, you are changing it. Negative, negative. What is negativity? You you are reversing of it. If it is plus 1, minus 1, minus 2, plus 2. Reverse 3, minus 3, 4, minus 4. Negative of a matrix opposite to the given matrix. Okay, and how you can show? If it is capital letter A, so reverse of it, minus it, negative of it, change the sign. Okay, so you can get the negative of a matrix. Move on, next type, a very interesting, that is symmetric type. And you are considering a square matrix. How it should be symmetric? If it is equal to its transpose. Look at, I am taking this and I'm converting into rows into columns, rows into columns, rows into columns. You know, I have made transpose of this matrix. But what I am observing here, it is exactly same. Those numbers I'm taking these, they are the same. How it's amazed. That's why this matrix is known as symmetric. It's same overall. If you are making transports, they are not going through change. It having symmetric type. It's your symmetric matrix. So how it's symmetric? It is remains same while you are changing the rows into columns. You are changing the rows into column. You are changing the rows into column, but it should be same. So a square matrix is symmetric if it is equals to its transpose. Symmetry from everywhere. Now it's symmetric. The next type, but it's the skew symmetric. Skew. You know, if you are doing this, rows into columns, changing it, rows into columns, rows into columns, it's not same. But if you are reversing of it by minus of it, a transpose doing it, you are multiplying with the minus sign, then you can get the real exact the given situation. How? Look at, this should be same as the previous one. How we are getting it? By not only the transpose. First I am making transpose and then changing the sign. That's why it's skew symmetric. Skew. We change the screw, not the screw. In mathematics, not the screw, we are changing the sign. And that's why it's called the skew symmetric matrix. Now, the next type, that is diagonal matrix. How diagonally? You know the diagonally, you know the diagonal form, you know the diagonal form, okay? You know about it. So, if you are taking any square matrix, must remember it, okay? Where the number of rows and the number of columns are same, that should gives you square, okay? So in the square matrix, if the diagonal matrix are all the entries that is diagonally coming is not zero. It any number, but it should not zero. Diagonally not should be zero. Diagonally numbers those are coming. Look at, entries are different. Okay, but what about the leftover part? Leftover part, it should be zero. Look, diagonally are not the zero, but the leftover part, all the parts zero. Look at diagonally they are changed, but what about this? All should be zero. Look at this. Diagonally, it's having zero, but not diagonally or diagonally or. Okay. So what about it? Otherwise, all having the zero entries. So this is called diagonally. Okay. Diagonal matrix. Okay. So we can say it's these are diagonal. Yes, these are diagonal. Move on. The next type is scalar. You know, it's a kind of a diagonal matrix. Yes, but you know what are these? Having the same number. Look at having the same constant, having the same number, having the same number. While other entries should be zero, but diagonally those numbers are coming. That should be same. So that type is scalar. Okay, now what about the next? Interesting. In the next type, it should be same or it must be one. It should be same and it's only one. The rest of the entries should be zero, 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 zero. So this kind of the matrix is known as identity matrix. The another name of identity matrix, it's called the unit matrix. It's denoted by capital I. Look at it's order 2 by 2, it's order 3 by 3, it's order 1 by 1. We can say it's also diagonal, it's 1. The rest of the entries that are not shown here should be 0, 0. Okay, so all your identity matrix. Yes. So, any question comes in your mind, we have already discussed each and every type of matrices and learned a lot. So, if you have any question, you want to ask any question, write it in the comment section. So, subscribe Math Magician channel. Many tips and tricks for you. Happy learning. Thank you. Bye.